All right, let's dive right into this explainer. We're looking at a massive breakthrough today that is completely revolutionizing how we track athlete stamina. We're talking about moving away from a world of really expensive, clunky hardware into a future driven entirely by invisible algorithms. The source study we're analyzing today asks a pretty bold question. Can standard television broadcast video actually replace the super expensive tracking gear that professional athletes wear on the pitch?
So here's the million-dollar question on the pitch. How do we actually know the exact split second an athlete is running on empty? In high-stakes environments like professional soccer, fatigue isn't just about feeling a little tired. It's a biological tipping point. But spotting that tipping point is incredibly tricky. You've got 22 athletes running dynamically over a massive area. How do you objectively measure when a player's tank hits zero before a catastrophic injury actually happens?
And that's exactly why we're moving away from the old ways of doing things. I mean, think about it. The old way of measuring fatigue relies heavily on subjective surveys, literally asking a player how they feel, or running laboratory biomarkers like blood and urine tests. Those are just way too slow to help you during a live match. Even modern wearable GPS vests are proprietary, incredibly expensive, and really limited in scalability. But the new way? Our source material outlines something called Game State Reconstruction. This leverages AI and standard monocular broadcast video, literally just single-camera footage, to track absolutely everything.
Okay, really quick roadmap for us today. We're going to cover the hidden cost of fatigue, the problem with current wearables, and how video acts as an invisible sensor. Then we'll crunch the kinematic data, build the athlete profile, and look at the future of sports. Right, Section 1, the hidden cost of fatigue, and why tracking stamina is an absolute big deal. Because fatigue, it's way more than just needing to catch your breath. It directly causes game-losing tactical errors and severe injury risks. The researchers point out that fatigue is a multifactorial beast. It's part metabolic, like glycogen depletion, but it's also about microdamage to your muscle fibers. When that fatigue really sets in, you get a disproportionate loss of spatial control on the field. The athlete loses their force-generating capacity. That translates to a slower reaction time, a missed tackle, or far worse, a huge increase in the risk of tearing a hamstring.
Moving on to Section 2, the problem with wearables and the flaws of our current tracking methods. So the reality is, current methods just don't cut it. They're too slow, way too subjective, or rely on insanely expensive, intrusive gear. Like we mentioned, you obviously can't draw a player's blood in the middle of a 45-minute half to check their metabolite accumulation. And sure, wearable GPS systems do provide highly accurate spatiotemporal measurements, but they are physically strapped to the player, they're proprietary, locked behind massive paywalls, and they simply do not scale. A local amateur team just isn't dropping $1 million on a multi-camera or wearable GPS system.
Which brings us to Section 3, video as the invisible sensor, specifically using monocular broadcast videos.
Now, this concept right here is where it gets incredibly cool. It's the heart of Game State Reconstruction, taking standard video feeds and transforming them into complex biomechanical data without a single physical sensor. By tapping into deep learning models that were originally developed for things like the soccer net challenges, the AI can actually detect a player, recognize the jersey number on their back, and track them across the broadcast footage. It literally takes the passive video you'd watch on your couch and turns it into an active, highly scientific sensor. Mind-blowing, right?
All right, Section 4. Let's crunch the kinematic data and see how we actually turn those pixels into coordinates. So how does the math work? The system uses camera calibration to project those player detections onto a 2D metric field, which gives us their exact X and Y coordinates over time. When you really think about it, it's amazing. It takes a flattened map of the soccer pitch and mathematically links it to the angled view of the TV camera. Once the AI understands the dimensions of the pitch, it calculates exactly where player number 7 is standing, down to the exact meter, frame by frame. To make this work flawlessly, the pipeline is broken down into 3 manageable steps so the tracking data stays reliable, even when players are briefly obscured. First up, you extract the raw trajectory, basically finding the players. But players block each other from the camera's view all the time, right? So step 2 is short gap interpolation. If a player vanishes for up to 3 frames, which is about 0.12 seconds, the system linearly connects the dots. And finally, we have temporal smoothing, which is absolutely vital for getting accurate speeds. Why is that smoothing so vital? Because calculating acceleration from video frames introduces a ton of jumpy, high-frequency noise. Think of it like radio static. So the researchers apply what are called Kalman filters to smooth out the data. Imagine the AI's bounding box around a player jitters even a few pixels between frames. The raw math might mistakenly calculate that the player just accelerated at a biologically impossible rate. It's just noise. The common filter acts as this really intelligent shock absorber, smoothing out that positional static so we get a true, clean representation of the athlete's actual motion. And you really can't argue with the results. When plotted against a highly standardized dataset, the AI's predicted trajectory tightly hugs the actual ground truth line. The algorithm is predicting the exact running path of a player with just astonishing precision, purely from the video. It essentially proves that this invisible sensor isn't just theory, it absolutely works in practice. Let's jump into Section 5, building the athlete profile by mapping speed versus acceleration.
Okay, so we have their location, speed, and acceleration. Now what? Well, we build an acceleration speed, or AS profile. It's a linear graph modeling the relationship between a player's instantaneous acceleration and their running speed. This becomes our ultimate fatigue indicator by plotting exactly how much explosive power an athlete has left at any given speed. This is a massive concept in modern sports science because it essentially maps out a player's physical capacity. When you're standing still or moving slowly, you have the potential for massive explosive acceleration. But if you're already in a full sprint, your capacity to accelerate any further basically drops to zero.
To break that down, here is what these metrics actually mean on the pitch. A 0 is your theoretical maximum explosive power, how explosive you are off the mark. Think of a super nimble winger. Then you have S0, which is your theoretical top running speed. The slope of the line that connects these 2 points, that tells us everything we need to know about their current state of muscular freshness. It's the crucial balance between velocity and acceleration capacity.
And here is the absolute kicker. When we see that slope steepen over a 45-minute half, that translates to real-world danger, a prime setup for a game-losing mistake or a pulled hamstring. The research shows that as the game pushes into the second half, the athlete's ability to generate force at higher speeds diminishes. The slope drops faster. And the AI, it's actively tracking this steepening in real time, just from watching the TV feed. It's essentially sounding the alarm that the player's muscles are failing, all without a single wire touching their body.
Finally, Section 6, the future of sports and democratizing science. This leaves us with such a fascinating reality. We are literally entering an era where insights that used to be strictly reserved for the top 1% of elite teams can now be generated by a high school coach with a tripod and a laptop. If this low-cost, invisible tracking democratizes sports science for everyone, how is that going to permanently change the competitive landscape of sports entirely? Really makes you think, doesn't it? Well, that wraps up today's explainer. Thank you so much for tuning in, and keep questioning the data.